Hello everybody and welcome to part 5 of my review of the IniBuilds A340-300. Today I'd like to show you a few more things the add-on is capable of, and I will explain that in a second. So let's board the flight deck. Alright, here we are. I prepared everything already, so the plan for today is to do a takeoff on runway 25 center. I inserted a departure road, which is the ANEKI 6 Foxtrot, it's the ANEKI 3 Foxtrot departure. So we are here, runway 25 center, we do the takeoff and fly this track here and then southbound. Initial altitude is 5,000 feet, but we will climb to flight level 150. While in cruise flight, I'd like to show you a few things regarding the flight control system. So we have a look at the bank angle protection. I can show you the overspeed and the low speed protection, which works quite nicely. Not as good as in the real aircraft, of course, but it does work. Then I'd like to answer a question regarding derates. We do that in a minute. And then we just turn around and fly a fully automatic RNAV approach to runway 25 center, which is going to be this one here. Let me just grab the approach chart. So it will be the RNAV, the RNP X-ray to runway 25 center. I already programmed that. It's beginning at point 𝐶𝐿 at 5,000 feet. Then we follow this track here towards the runway. We have a few altitude constraints, as you can see here. This means at or above 4,200 feet, at or above 3,000 feet. And then retro is the final descent point, which we should pass at or above 2,000 feet. I did this approach a few times. I tried it out with the add-on, and I have to say it doesn't work that well all the time. It does work, but it depends on how you approach the final course, and I would suggest we just try it out and see what the systems are making out of it. So I programmed the FMS already. I did the takeoff performance. We have 30 tons, almost 30 tons of fuel. I calculated the takeoff at config 2. Takeoff weight is nearly 190 tons, so that's basically maximum landing weight. I inserted all the numbers here, and the flight plan is inserted as well. So you can have a brief look at what this is going to be. And if we go to the plan mode, you can see even better how this is going to work out. So this is the departure, and here we already have part of the approach. Okay, before we take off, I'd like to explain something regarding derates. Somebody asked about that, so there was a question in the comments. So normally we try to take off with as much reduced power as there is available for the ambient conditions. So like for this, we have an outside air temperature of 14 degrees, which means in conjunction with the weight, as we are not heavy, we can reduce the thrust for quite a bit. For quite some amount, and this is called the assumed temperature method. So that is what this temperature here has to say. So this basically means that the system thinks the outside air temperature is 53 degrees, and it has to reduce power in the engines in order to save some engine life. This is just a basic explanation, but that would go too far. So basically, we say it's warmer outside than it actually is, and that gives us a reduced takeoff thrust. And here we have the thrust reduction and the acceleration altitude. The acceleration altitude is that altitude at which the aircraft lowers the nose, or if we fly manual, we lower the nose in order to retract the flaps. So that's the acceleration. We speed up and retract the flaps. And the thrust reduction altitude is the altitude where we go from takeoff thrust to climb thrust. And normally, you can see that on the next page. This is the climb phase, so it's the performance climb page. And here you have this DRT CLB, that's called D-rated climb. You can enter a so-called D-rate there. So as soon as you retard the thrust levers to the climb detent, the system sets climb thrust, and if this cyan thing is blank, it goes to full climb thrust according to ambient conditions. But if you enter a D-rate, like for instance D1, it sets a D-rated, so a reduced climb thrust, or you can even go to D2, which reduces the thrust even further. And as the A340-300 is not the best performance-wise, you might already know that, we have to be very restrictive with this D-rate. And the normal procedures say if we have a takeoff weight of less than 210 knots, we are allowed to, 210 knots, sorry, about 210 tons, we are allowed to use D1. And if we're even lighter than that, below 190 tons, like we are here, we can enter D2. But it does climb very badly with the D-rate, so normally we don't use that. But anyway, we can do that today. So I enter D2 as we are below 190 tons. And as soon as I reduce takeoff thrust at the thrust reduction altitude, which is 1,000 feet above ground, then here you can see the auto thrust system go to D-rated climb 2. And then I can show you what happens if I delete the D-rate and we go back to normal climb power. So that's the plan for now. Okay, let me just have a quick look if we did everything. This is looking good. There's a message I need to address just real quick. That's the load sheet the system sent us. There we go. But I already entered all the numbers, so we don't need that. All right, guys, you ready? So normal takeoff with reduced thrust. Then we climb straight ahead, follow this departure route. You can see we have an altitude constraint of plus 800 feet here at the point delta Fox 134, which means we have to be higher than 800 feet at this point, which shouldn't be a problem. Then we do the left turn, and we have a speed restriction of 210 knots until delta Fox 137. And you can, if you want to plan ahead and see which flap setting you need in order to cope with that constraint, you can just have a look at your takeoff performance page. You can see flap retraction is at 166 at F speed, slat retraction at 182 S speed, and minimum clean this one is 229, which means 210 would be below that, but above F speed. So we have to fly at least with config 1 until passing this point before we can accelerate further. All right, let's take off. Let me see. Parking brake is off. I set everything. Okay, and I go for flex power, so man flex 53, SRS runway, auto thrust blue. Little bit of forward pressure. And here we go. Yeah, we release the pressure until 100 knots. And then at VR, we rotate to around 12.5 degrees pitch, which is now okay, 12.5 degrees. Need a bit less than that due to performance and gear up. Okay. Yeah, this looks nice. 800 feet and the left turn. Okay, I'll leave that to the autopilot in order to be able to explain a few things. Now you can see lever climb. We passed 1000 feet AGL. So I go to climb thrust. And now you can see the derate thrust, derated climb 2, and auto thrust is active. This is what it means. So we passed F speed. Now we can go to flaps 1. And at first, the system puts the flaps to 1 and the slats to 1, of course. So it's 1 plus F. But if we accelerate through a certain speed, the system automatically retracts the flaps, which is now, and that gives us a little bit more space to maximum speed at this time. Okay, now comes the speed constraint. And we continue climb to flight level 150. Now you can see the speed bug is still held by the system, 210 knots. As soon as we pass the constraint, it will jump to 250 knots. There we go. So now we're accelerating 250 knots. We passed the S speed already, so we can retract the slats and disarm the speed brakes, the spoilers. And there we go, 250 knots. Now we wait until we have the 250 knots so we can see which climb rate results with derated climb 2. But we are just about to pass the transition altitude, so we can just go to standard on the altimeters. There we go. So now you can see, although I have to admit I didn't test that in advance, so hopefully we can see something. So now we have almost 250 knots. We have a climb rate of 2,400 feet per minute, yeah, 2,500 feet per minute. Now I go to the performance climb page, and let's just clear the derate. So 2,400 we have now. Derated climb 2 is 87.2%. Now I put in D1. I clear the derate. Thrust climb is the mode. 92.1 is the power setting, and you can see 3,200 feet per minute. That's quite good. I would say that's a bit more than the actual aircraft would do, but anyway, it just should give you an idea what the difference is. If I would put in D1 now, let's do that real quick. So we have 92% and a rate of a bit more than 3,000 feet per minute. So I go back to thrust derated climb 1. You can see it reduces by almost 4%, 88.4%, and we have about 500 feet per minute less climb rate. So that's what the D rate is about. But let's go to full again. So there we go, thrust climb. So now the armed mode is altitude cruise because I inserted flight level 150 as cruising level, and the aircraft will climb to flight level 150 now, as I set that on the FCU here. Okay. But we don't need to fly that fast. It takes us too far away from the airport. Just let's go to 270 knots. And I think we did everything. Yeah. So here's ANEKI. That's the end of our departure route. And now wait, I'll take this one, the nav mode. Airport is here, so that's where we are going to do. That's where we are going to go later on. But for now, we keep this. And one thing, yeah, we need to reduce our climb rate a bit. So now we have speed, vertical speed. It means auto thrust is in speed mode. And I have a fixed climb rate, 1,000 feet per minute. So the auto thrust tries to maintain the speed by adjusting the power. So you might ask yourself, what happens if we fly through over ANEKI? Because the flight plan is open there. We have a discontinuity after ANEKI. You can see that here, flight plan discontinuity. And well, that's quite an easy one. As soon as we pass ANEKI, the system does not know where to turn to, so it just reverts to basic heading. So we go into heading mode automatically. You can either do it here, heading, or go back to managed mode, and then it will revert to heading mode as soon as we pass ANEKI. All right, what are we going to do next? So next I will fly manually and give you an idea about of the back limit protection, which means normally we are using this range, so that's 10, 20, and 30 degrees, or cruise star. And according to our regulations, we are not allowed to go beyond 30 degrees. The Airbus, the flight control system has a bank angle protection sort of thing. So as soon as we pass through 33 degrees, so let's say we steer with 45 degrees bank and release the stick, the system goes back to 33 degrees. That's the maximum the system will hold. And if we only steer 45 degrees, it will still maintain altitude, but without having to pull back pressure. But as soon as you go beyond that, then the nose will drop. Yeah, that's about it. So let's just try that out. Set manage speed. I'll delete that. So now we're about to pass ANEKI. Yeah, we can do that all together. So autopilot off. I leave the auto thrust on because I don't have a throttle segment, and doing this adjusting the thrust with the keyboard is quite a hassle, so I leave that. So we just remain in auto thrust. Okay, so you can see I do nothing. Astonishingly, we left our heading, but anyway, So now I'm going to do this. No, wait, we just wait for ANEKI. I'd like to see that, if it really reverts to the heading mode, if the add-on does that. It's just a mile left, so we should see. Point 5, point 4, point 3, point 2. Oh, you can see it here, by the way. And you can see, okay, flight plan discontinuity is ahead, and system reverts to heading mode. Oops, sorry, I forgot to steer. Okay. One thing, it's a little tip. If you want to fly manually in the Airbus and don't use the flight director, you can switch that off. You can use something very neat. It's here. You can go to track, and then you have this little thing here. That's the so-called birdie. It's the flight path vector. And you can see where the aircraft is going. I get that little bigger. So here you can see the wings, which are these, are slightly above the horizon. That means we would climb. Now it's getting a little bit below. So if you want to hold the altitude, just put the wings on this white line here, and you should be good. And we don't have a little bit of crosswind, so you can see this symbol here is a bit diverted to the left, and that shows you the drift. Okay, if you want to fly a turn, just put this on the horizon and you can maintain your altitude. But I want to show you the bank angle protection. So although this is fly-by-wire and the system does it all by itself, you need some back pressure just initially because the system is a bit slow. But here you can see 33 degrees almost, easy peasy. If I go further, now I have stick input. I need to maintain the stick input in order to increase the bank. And if I release it, it goes back to 33 degrees. Once again, 45 degrees. Now I'm going beyond that. I have to pull. I have to pull. And if I'm releasing, it goes back to 33 degrees. That's what I wanted to show you. That's the first one. So let's go back to 150. Heading is not so important at the moment. Okay. Now, next thing I would like to show you is something you can see here. These green, how do you call it? These green stripes mean that we are in normal law. Normal law is the normal flight control law, where all the protections are active, and as soon as this is green, everything is fine. So with this protection, I can show you, with this controller, I can show you the protections. And why don't we start with the low speed protection? So I put the power in idle, auto thrust is off, of course, and then we are going to maintain altitude. And you can see the slower we are going to get, the more pitch I will need in order to maintain altitude. And there's another tip I can give you. It's an optical, a visual thing. So you can, the difference between this and the symbol is roughly the angle of attack. So if this is the nose of the aircraft. So if the difference between this, so if the angle of attack is high, the chances that you stall the aircraft are very high, which shouldn't happen in normal law because everything is protected. But I can show you if we are in a different control law, which we are going to do in a minute, then you in fact can stall the aircraft. But you can see I'm doing nothing on the stick. It's just very, very easy to steer. It holds the altitude, but the angle of attack is rising. You can see that the difference between those two is much larger than in the beginning. So what does the low speed protection? Well, basically it does two things. As long as the auto thrust is functional, it doesn't have to be active, by the way, but as long as it is functional, it will go into, I'll explain in a sec, you have to see it, but it will jump in and give power in order to prevent the stall. And the other thing that the aircraft out of the flight control system does is it lowers the nose. So here you can see that's the lowest selectable speed, the VLS. This is the alpha protection. It's related to the angle of attack. So here the protection should jump in, and this is the alpha max. So that's the maximum. If you go below that, which you cannot in normalo, but if you go below that, the aircraft will stall. And it's all very nicely simulated. I'm very, very happy about that. IniBuilds did a very good job. As mentioned before, it's not as precise as in the real aircraft, but hey, this is a simulation, so come on. So now you can see we go to alpha protection, alpha floor mode. That gives me full power. And now we have toga lock. That means toga power is active and locked, so I have to move the thrust levers in order to regain control of them. So we just accelerate. And here you can see the angle of attack has decreased already. So we're good. All right, so now let me take control. We go to climb, toga, climb. That's not working. Just a second. Okay, man toga, this is fine. We go to climb and not localize auto thrust on again. You can see it here. And back to 150. And now I'm going to show you the high-speed protection. High-speed protection is a bit different. It's mainly a pitch command the aircraft will execute. It doesn't have to do anything with thrust. Because I can set toga power now. You can see man toga. Auto thrust is armed but not active, so I have to put the thrust levers in a different notch in order to activate the auto thrust. But we leave it like that. So I'm not steering anymore. Hands are off the stick and just watch what's going to happen. Of course, the overspeed warning might come on. There you can see. So overspeed, it does not go beyond these green things here. And now you are in control again. You should do something. So let's just go back to climb thrust. Auto thrust is active. We go down again. I need to turn around. Oh, sorry. I need to turn around, otherwise we're too far away. Let's see where we are. And then we will revert the flight control system to alternate law. Okay, let's do a heading of 050. 050 is good. Okay. Good. Heading 050, we go back to flight level 150, roughly 150. It's not that important at this time. And then we go into alternate mode. Normally the alternate mode is going to be active if you have failures of some sort. There are some failures that result in alternate mode. Sorry, I'm mixing up the 787 things. So alternate law it is called. And if you have certain flight control failures, flight control computer failures, then the alternate law will be active. So let's go here. This is fine. And I cannot put in any failures here, so we just have to do that manually, and that's done easily. You just have to switch off two ADRs. Two air data computers. We just switch off ADR 3 and ADR 2. And now you can see, yeah, ADR 2 plus 3 fault. We don't do that at the moment. And then we have flight control alternate law, which means protections lost. Although we have a few basic protections in alternate law, but basically all protections are lost. So in this state, you can stall the aircraft. Okay, I need to cut the power. And now you can see alternate law also means we have no flight director. But as I switched on the flight path vector before, it's being displayed now. And we have amber crosses where the green stripes were before. This means the control law is degraded. And here you can see maximum speed is 305 knots or Mach 0.82, rudder with care, because all the flight controls are more direct now. So it's a lot more responsive than it was before. And now let's do a stall, shall we? Yeah, let's stall the big bird. Okay, so power is at idle. You can see it here. And yeah, this takes a while. Let's just put in some speed brakes. This goes faster now. I just want to demonstrate the stall. That's all I want to do. And there even is another control law below this, which is called direct law. Let me just put this up again. And in direct law, you basically have a conventional aircraft. So you have no auto trim anymore. Here you still have auto trim. So in direct law, you have no auto trim anymore. So you have to trim manually with this wheel here. And all control inputs are very, very direct because they're not filtered by the flight control computers anymore. So why doesn't the aircraft want to slow down? Okay, sorry that this is taking so long, but I just want to demonstrate that real quick. But let's fly a turn because I want to go to CapCut later on. Oh, have you heard that? Stall already. That was because the angle of attack is already quite high. I would have said that the actual aircraft is a bit more forgiving than this, but anyway, angle of attack is quite high, so you have to be careful. Normally I would do the recovery right now at the first sign of stall. May it be this is stall. So we push to unload. You see, we reduce the angle of attack. Wings level. Normally we add some power and then we recover and try to gain back speed and altitude. I need power. Climb power is good. Yeah, this is fine. Okay, let's just set about 60%. That should be enough. All right. Now, I can just quickly show you the direct law, but I will switch these on again first. Yep. Everything is normal. Flight director is working as well. Heading. Yeah, thanks. So altitude is not important right now. So now, in order to get direct law, we switch off all the main flight control computers, which are Prim1. Where is it? Prim2 and Prim3. So now you can see flight control, direct law, protections lost. Speed brake do not use, maneuver with care, and in the PFD use manual pitch trim. So now I would have to use the pitch trim wheel in order to trim the aircraft. But it does work. We used to train that in the simulator from time to time, and it does work. You just need to be patient because trimming is not that precise, like in a Boeing, for instance, but it does work. And you can see if we go to the status, you can see what impairments we have. So this is almost, we are not supposed to use the speed brake for landing. We need to use flap 3. We need to do the landing distance procedure, which means landing calculation with this fault and manual pitch trim. Use. Yeah, that's about it. Okay, I would say this is all for now. Let's switch these on again. And let's prepare for our ANAF approach. So I switch on the autopilot again and the auto thrust as well. We need to go into the climb notch. Let's go to a heading of 090 and prepare for the RNP X-ray 25 center, which is here. And hopefully this is going to work as I'm planning to. So we need to lose some altitude. We go down to 5,000 feet. Yeah, and let's see. We have a track from Kuguk to Delta Fox 9070323. If we reverse that, it's 143. So we go to Kuguk, radial in 143, and pull the heading again. I need to push that. Yeah. And pull the heading again. And now you can see I have a nice track inbound from Kuguk to Delta, inbound to Kuguk. I'd like to intercept that, but we need to lose altitude first. So full speed brakes. And let's get down to it. Then I prepare the FMS. Approach phase active, but I didn't insert any numbers there. Temperature was 14. And we have a minimum descent altitude of 840. Yeah, this should work out. Let's see, 8 miles we go on a parallel track. Yeah, this is good. And we're already there. No. Sorry. And I have to set the QNH and reduce speed to 230 knots. Yeah, clean speed is 226. So we have 7 miles to COGUC. We are at 5,000. Speed is a bit high, but this is good for an inbound turn. So we do it like this. And there are several possibilities or several options to fly this RNP approach. I'm going for a fully managed approach, which means that we will use the approach mode. And then we have all the constraints. Let me see if they're correct. Sometimes it's not working properly. Yeah, COGUC 5,000 or above. Delta Fox 907 should be 4,200 or above. Delta Fox 901 is 3,200 or above. And RATRU at 2,000. This is important. This should be the one to aim for. And then we have a 3-degree glide path. Yeah, that's fine. That's how we need it. Okay, so now we're getting closer. I go to flaps 1. And we reduce the speed further to 190 knots. So now we are almost inbound COGUC. I go into nav armed. And then we intercept the final course. And I can show you something else, but just in a sec. Let's just have a look at the approach chart. So here you can see we are here, we're going there, and there is a specialty with the approach mode. We are allowed to use the approach mode only when we are inbound the final descent point, which is RATRU. So on this leg, I can activate the approach mode. And we do it with the managed descent mode before that. So now we are inbound COGUC. Just before COGUC, I will dial in 2,000 feet. We want to be at 2,000 feet by RATRU, and then with the approach mode, we proceed further. Yeah, 4 miles left. Yeah, I just have a look outside. Nice weather today, a bit cloudy. What do you say, first officer? Okay. Nothing. Good. All right. So 3 miles. We are in altitude mode, so I can already dial in the 2,000 feet and push. And now you can see a different mode. It's constrained, altitude constrained, and managed descent is armed. So in order to help the system, we go to flaps 2, reduce the speed to 180 knots. And here you can see, even this is magenta, which means that the system is coping with the constraint. Normally this should be magenta as well, as far as I remember, but anyway, as good as it is, as long as it works. So now it should descend to 4,200 feet, but there seems to be something different. Okay. It says we're low, we are 3,860 feet low, which is not correct. So we need to do this. 4,200 we want to have there. And the constraints are correct. Okay, now you can see descent, alt in magenta. This is the constraint. But at Delta Fox 901 we want to have 3,000 feet. Yeah, so that's a little downside here. It's not working that good. It did work one time, but not at the moment. That's, yeah, it's a pity. It's always so. If you want to show it to somebody, it's not working. But now it's working. And you can also see the little dot here, which gives an idea of the vertical path. So now we're getting a little bit high. Thrusters at idle, aircraft is descending. Yeah, we can help by extending the flaps further. I will do that. Let's do flaps 3, which is non-standard. Little bit room to the maximum speed. Yeah, extend speed brake. The system says I'm not able to match that. We need to extend the speed brakes, but we still have almost 7 miles to run through. Should work out. Yeah, but let's go to manage speed and help with a little bit of speed brake, and then it should work out. I'll help with the speed in order to go down a bit. And an important factor, an important point is you can see speed brake still out is okay. We go to manage speed again. You need to have this little arrow here. This shows the final descent. We need to have that in order to make sure that the system is flying the correct angle. So now we're inbound RATRU. I can arm the approach. So we have approach nav, final blue. Extend speed brake is nonsense because we have 5 miles left to RATRU. We are at flaps 3 already and almost at 2,000 feet, so this is perfect. Alt star. Now we can put in 4,000 feet. No, we want to hold that. Yeah, normally in the aircraft you can just set a higher altitude when you're in the altitude mode or alt star mode if you're fast enough, and the system just maintains the 2,000 feet. Okay, so now we're quite low already. So with intercept of the glide path, I will lower the gear and put the final flaps. And then we are on our final approach to runway 25 center. One more thing, this system is programmed in a way, as it is a bit older, is programmed in a way that it just flies down to minimum and then reverts to basic modes. And policy is when you fly through minimum, you have to disconnect the autopilot at the latest, or before when you have the runway in sight. but will fly automatically as long as possible. So now you can see we have the vertical deviation bar. It's coming in. So this is our glide path. It's not as precise as the glide slope with an ILS, but it's good enough. I mean, this is a non-precision approach, but this is quite good. So now the system intercepts the final course, and we put the gear down. Speed brakes, spoilers armed. I always say speed brakes because on the 787 these are the speed brakes. And now we have final approach. So all modes as we wanted to have. And the final flaps. Landing checklist. And here we go. So now I will fly to MDA 840 and just show you how the system reverts to basic modes. And then we do the landing. Checked. Ah, beautiful, isn't it? And really, it's so much like the real thing from the visuals. It's so nice. I'm still very pleased with this add-on. Thank you, IniBuilds. This is great. Okay, here we go. You can see the fluctuations in the pitch. This is because it's not that precise, but the aircraft is much more precise. Just... Okay, now we have minimum. It should revert to basic modes. There we go. Autopilot off. We need to increase the descent rate a little bit. This is strange. No lateral inputs, and we go away from the center line. Nice. Okay, okay, I'm steering back.
70, 60, 50, 40, 30, 20, 10, 5, retard.
And reverse. Yeah, sorry. Normally we try to land on the center line, which works 99.9% of the time, but this was strange. I didn't have any input with my stick at all, and it was drifting off. Okay. And here we are. Back again. Parking brake. And let's see if everything is in order with our beautiful aircraft. Yeah, this looks nice. So we can put down the the spoilers. All right, guys. I hope you enjoyed this a little bit. It was longer than I planned it to be, but maybe you got some insight now on a few systems, and maybe you want to try the RNP approach yourself. If you know which buttons to press and how to plan ahead, it's quite doable. But I would recommend in the beginning just to do the ILS approaches. It's much easier to fly them even by hand. So that would be my recommendation. Okay, that concludes part 5. If there's anything you would like to know, as mentioned in the other parts as well, please leave it in the comments. Ask questions, request things I should do, I should explain, and I will gladly do that. So for now, I thank you for watching. Please leave a like, helps the channel. Subscribe, helps it as well. Comment, helps the algorithm. And of course, I'm interested on what you think and what you want to know and what your questions might be. So much for now. I wish you all the best, and I see you in the next one.